Hello, let's begin our class. Uh, this Monday, I updated the course website, and you can check the accuracy results of assignment 3. And assignment 3 will not be updated as the deadline has already passed. And I also updated the quiz results. You can check your scores in the previous week. And yesterday I updated the accuracy results of assignment 4. And if your accuracy is not 100%, but you think your program pass all the input-output samples, then you need to examine your source code. You need to pay attention to whether the variables are properly initialized, or any index out of range issues in your code. So you can pay attention to the two issues. And I also posted assignment 5. Assignment 5 is our last assignment, and I will explain the contents of assignment 5. The next week we will have a teaching evaluation survey, and after that we will have a roll call. So please remember to attend. And here is the assignment 5. Assignment 5 is to write a system to track top 5 scores. And this system supports 4 commands: add, delete, show, and exit. I already upload a template, so you can see the template. This template already implements the show function. So here is the code template, and you can try to run this program. So now you can enter one of the 4 commands. So for example, you can enter show. Then the program will display the leaderboard, the top 5 scores. And initially, the scores are set to 0, and the name is set to anonymous. And when you press exit, then this program terminates. And you need to implement the add function. You need to implement the add function. Then you input a score followed by a name. And then when you enter show, the program will display the top 5 scores. But because I haven't implemented the add function, so currently we didn't see the changes because we haven't implemented the add command. So the command should display the name and the score of the top 5 players in descending order. And the command exit terminates this system. And we need to implement the add function. The add function takes a score and a name from the user. The score is within the range of 1 and 99. So let's see the example. The example is below. So when you enter this command, then the leaderboard should like this. So when you So when you enter this command, so when we enter this command, add 94 Aubrey, then item 1, you should modify. If a user enter this command, then you should modify the leaderboard, and the output should like this. And when you enter, when the user enter this command, then the leaderboard should be updated. So after the second aid, the leaderboard should be like the leaderboard is in descending order. So larger scores will be in higher items. And when you enter the third aid command, here the input score is 62, and this score is the same as the one of the previous score. We have some previous score is also 62. Then you need to determine this item should be above or below this item, and according to the instruction, if the enter score is greater than any of the top 5 scores, it will be added. So according to this rule, this command should the later input should be below previous input. So after this command, the leaderboard becomes so if the input score is the same as previous score, then this item should below the previous item, according to the instructions of assignment 4, assignment 5. And if this condition is not satisfied, if one item is added to the leaderboard, then the lowest score will be removed. So when I added this item, the lowest score will be removed. And if the enter score does not satisfy this condition, then this score will be discarded and will not be used in the future. So here is this remark. This system does not record items that are not in the leaderboard. Suppose you enter one item and this item is not added to the leaderboard, then this item is discarded and will not be used in the future. So after the 5.8 commence, and if you enter show, the leaderboard will become this one. And next, we need to implement the delete command. The delete command read one score from the user, and the record on the leaderboard matching this score will be deleted. And if this happens, then a new entry for anonymous with a score of 0 will be added at the end of the leaderboard. So let's see the example. For example, the user entered delete 62. Then we need to find score 62 in this leaderboard. Then we find two items, item 3 and item 4. Both have 62. And we have one additional rule. So the additional rule is here. If multiple records share the same score, then the earliest one entered will be deleted. So if we find multiple records with the same score, then we need to delete it, the earliest one. So in this example, we need to delete item 3 because it is the earliest one. So the delete command will delete item 3. And after item 3 is deleted, we need to add one item at the end. The anonymous item with score 0 will be added at the end of this leaderboard. And we have another condition. So if you enter delete 63, however, we cannot find any score. We cannot find any score in the leaderboard that matches 63. in this case, the leaderboard remains unchanged. So if the enter score does not match any record on the leaderboard, then the leaderboard remains the same. So here we enter delete 63, and 63 does not match any score in the leaderboard. So the leaderboard remains the same. And let's take a look at the code template. In the main function, we have two function code. The first one is interactive test. The second one is non-interactive test. The second one is for you to test your program. So you don't need to perform interactive. You don't need to manually enter commands. So if you want to test your program without manually input commands, then you can use the second function code. However, when you submit your program, you need to use the first one. You need to use the interactive test. And let's see the details of this function. It is at the end of this template. So the interactive test first will read a command from the user. And if this command is not exit, then we will enter the while loop. And if the command is show, then this program will call the display items functions. So let's see the display items. So the input of the display items are two vectors. So the first vector is the first vector contains the 5 scores, the top 5 scores, and the second vector contains the corresponding names. And this if command will check whether the size is equal to constant, name scores constant. If score start size is not equal to this constant is set to 5 because our leaderboard has 5 scores. So this constant is set to 5. If the size of this vector is not equal to this constant, then program will show some error message and terminate the program. So you need to ensure that the vector is always the size of this vector is always 5. And then the following for loop will display the items in this leaderboard. So here is the name at index I and the corresponding score at the index I. So so you don't need to you cannot modify this function, or you cannot add additional line break, or you cannot delete the space. Otherwise, your program will not be evaluated properly. So here, here we use type DAF to define an alias for this data type, a vector of integer. So we use type DAF to give an alias. This alias is score vector. We use this for as an alias for a vector of integer. And similarly, we define name vector as a various alias for the data type, a vector of string. So you see that here the display items accept two inputs. The first input is a vector of integers, and each integer is a score. And the second input is a vector of strings, and each string denotes the name. And here we use call by reference. We use pass by reference because the ampersand operator. Here we use call by reference. You can also use call by value. So if you want to use call by value, you can remove the ampersand operator. So you can also declare function like this. But this one is not memory efficient, because when you make a function call, you need to copy the vectors. You need to copy the entire vectors. So this is not memory efficient. So we seldom use this one. We prefer the use of call by reference. Here we add the const modifier because we do not modify the two inputs inside this function. So here scores is a vector of integers, and names is a vector of strings, and the function call initialize system will initialize the two vectors, and let's see its implementation. The implementation is simple. We simply use pushback to add some elements. So so this for loop will will add 5 scores, because number of scores is set to 5. And here we cannot add const here, because we modify scores and names. So here we cannot add the const modifier, and we still use call by reference because it is more memory efficient. Oh, and we have to use call by reference here, because we need to modify the two inputs inside this function. And if the user enter the add command, then the if statement will be executed. The cin will read a score and a name from the user, and the two inputs will be the first two arguments of the add item function. So this function will modify scores and names based on the user inputs. So you need to adjust the two vectors inside this add item function according to the user inputs. So here, these assignments will require you to implement the add function. You need to properly modify scores and names. And if the user command is delete, then cin will read one score from the user. And this score is the first input of the delete item function. And you need to modify scores and names according to the user input. This is the second task. So the second task is to implement the delete item function. Inside this function, you need to modify scores and names according to the user input item value. And I also provide more input-output samples. For example, I provide 6 samples to test the add item function, and I provide 3 samples to test the add and the delete function. And you can use these samples to test your program. For this assignment, I recommend to use the functions defined in the vector library, such as insert, popback, erase, pushback. This can help you to quickly finish this assignment. If you don't use these functions, it is okay, but it requires you a lot of effort to implement similar features. So I suggest to use existing functions provided by the vector library. And I also suggest to use the add member function instead of the bracket, because this expression can detect index out of range. If index out of range occurs, then this expression can detect the index out of range error. So you see that here in this example, I always in this template I always use the add member function to access elements in a vector. And you can also take a look at the non-interactive test. So for this non-interactive test, you don't need to manually input commands. You can make a function call to test your function. So here we directly call a function and the list does not require user input. Next, we will have a quiz. Please raise your hand if you need answer sheets. Anyone need answer sheets? Okay. And you need to close your laptop or tablet until the quiz is finished. This is the first question. You need to determine the value of sum after these statements. Uh, 30 seconds left. Then I will turn on the second question. The second question is to determine the values in the elements in list after these statements. 30 seconds left. Then I will turn on the final question. Uh, 30 seconds left. I will turn off all the questions. If you use answer sheets, remember to write down your name and student ID. So if you use answer sheets, please submit your answer sheets to me. Let's see the answer. The first question is option 2. So here we initialize this vector and we specify the range we want to copy. So array +1 is from index 1, so from 3. And we need to copy 5 minus 1. We will copy 4 elements, 4 elements. So the 4 elements will be copied to this vector. And if we sum the four elements, so you need to sum 3 plus 5 plus 7 plus 9. So the answer is 24. The answer is the option 4. The answer is option 4. So after first insert, we insert 1 at begin +2. So +2 is here. +1 if we have if +0 means the position before 5. So +1 means the position before 6. So +2 means the position before 7. So after this statement, we have 5, 6, 1, 7. And after the second statement, we insert 2, -1 in the same position. So we insert 2, -1 before. So after the first, sorry. So after this statement, we have 5, 6, 1, 7. And then this insert will insert 2 -1s at this position. Will insert 2 -1s before 1. So after this, the second insert, we have elements like this. So the answer to the option, the third question is option 3. Let's see this question. We need to determine size and capacity. So initially, both size and capacity are 0 because we do not perform any initialization. And the next one is resize. Resize will adjust both size and capacity. So after this statement, both size and capacity becomes 100. And then we have a for loop. This for loop will add 50 elements to score. So the size will increase to 150. And the capacity, when we enter this for loop in the first iteration, when we perform pushback, the size will double because you see this assumption. Whenever it needs to increase, the capacity of this vector doubles. So in the first iteration, the capacity will double from 100 to 200. And in the later iterations, we don't need to adjust capacity because capacity is always larger than size. So the answer to this question is you can try to run this program. You can also practice. For example, if I modify this command, if I change it to reserve, then you can determine what is the corresponding size and capacity if I modify this command to reserve. This should be 50 and 100. 50 and 100. I think the time is up, so let's take a break for 10 minutes. Hello. I think the recording problem is fixed, so we can continue now. We talk about the problem of missing C-in and the get line. And if we use C-in to read some input, then followed by get line, then if the user enter the new line, then we will have a problem. For example, the user enter 42 and the new line. Then the new line will be absorbed by the get line statement. Then we cannot read anything in the line variable, because the read line, if get line read new line, then get line will terminate. So nothing will be stored in the line variable. So in the example on the right hand side, when we enter new line, this new line is absorbed by get line, and the line is empty, so its size is 0. The remedy is we can add the ignore statement between C-in and the get line, and this statement can absorb the new line character. So here is the example. Now suppose we enter 42 and press enter. Then this enter will be absorbed by the new line, by the ignore statement. And then we enter some line, and this line will be read by the get line statement. So the line variable will contain fly me. Then we can try another example. If I type 42 and I enter some noise, then I press enter. The noise before enter will be absorbed by this ignore statement. Here 1000 means 1000 character before the new line. So the noise before the new line will be absorbed by the ignore statement. And then I enter one line. So we see that the noise is absorbed by the ignore statement, and the remaining input from me is read by getLine. So line contains from me. Next, I will introduce another function. One problem of the getLine function is that it cannot read the new line character. If you want to read the new line character, you need to use another function. For example, we can use get. The get reads one character at a time. So this is different from getLine or from cin. Cin can read a string, and the getLine can also read one line or a string. Here, the get function only read one character. So get cannot read a string, so get cannot read a string. It can only read one character at a time. And one property of get is that get does not skip white space, and also does not skip the new line character. So you can use cin.get to read white space and to read the new line character. We also have the put function. This function is similar to cout. So this function is not spatial. So you can always use cout to replace this function. The following slide introduce two functions, peek and pullback. I will use a video to demonstrate how to use the two functions. And you can go to our syllabus. And in the first week, we have a reference web page. And then you can go to the strings item. You can find the strings item. And here is a video. You can let's see this. Let's watch this video.
Hello, this is Robert, and in this video I would like to demonstrate how cin.get, cin.peek, and cin.putback work. I've set up this little demonstration inside of a graphics program so that I can represent what's going on graphically. So I've set up a stream buffer here, and this is controlled by the operating system. And so when the user types letters on the keyboard, the operating system keeps track of which letters are typed using a stream buffer. And you can see that the characters are filled in from left to right in this example. And so let's say that the user types A first, so that would be stored right there. And then they type a B. And then they type a C on the keyboard, and then let's say they type return. Okay, so when our program starts up, let's say that these are the first few statements in our program. So we set aside memory for ch1, which is a char. There it is right there. Then we set aside memory for another char called ch2, and there it is right there. So when we reach this first cin.get statement, that will remove the first character from the buffer and store it at memory location CH1. So the A goes from the buffer into CH1. And then what happens is the next character to be read moves over to the next byte right there. So when we have the next statement, cn.get ch2, B will be read from the buffer and stored into ch2, and then the pointer for the stream buffer, the next item to be read, will move over to C. If this is the end of our program, then the C will be thrown out. Otherwise, if there was another cn.get statement in our program, then the C would be read. Okay, so it's stored for further input, regardless. And if the program terminates, then it's thrown away. Okay, so
here we see the usage of cin.get. Our input will be stored in stream buffer, and cin.get will read character from the stream buffer. And you see here is a pointer. So cin.get will read the character pointed by this pointer. And after cin.get, the pointer will move to the next position. So this is the behavior of the cin.get.
So let's reset our program so that the user has typed A first, and then B second, and then C. So the first thing to be read will be A. But let's change our program, and we're not going to be using just simply get anymore. Let's use a combination of several statements. Okay, so we still set aside ch1 and ch2 right there. But the first statement to be executed is cn.peak. Okay, so peak is very similar to get, except that it will not move the pointer over to read the next item. Remember that that's what we did with get. With peak, we still will read the character from the buffer into ch1, and so we'll grab the A, but this time it's not removed from the stream buffer. So we did make a copy of the A to store it in ch1, but we didn't move over to read the B next. Okay, so with peak, we are still going to read the memory from the buffer. So the A went from the buffer up to ch1, but then the pointer stayed at A. So A was not removed from the buffer, and it will be the next thing to be read. Incidentally, notice that cn.peak uses a different style. With get, we have the character to be read inside of the parentheses right there. With peak, we can't do that. With peak, we have to use an assignment statement and actually store it to the left side of that assignment statement. You're not allowed to put any characters inside of the parentheses with peak. You'll get a syntax error. Okay, now that we have peaked and we've loaded the first...
we have seen peak is similar to get. Both peak and get will read one character from stream buffer. But the difference is that peak does not move the pointer. So the character still remains in stream buffer if we use cin.peak. And if on the contrary, if we use cin.get, after reading the character, the pointer will be moved to the next position.
Character into ch1. Now we will move on to the next statement right here. And so cn.get ch2. Well, the pointer is pointing at A right there, so the A will move into ch2. And then the pointer will move over to read B, right? Because that's how get That's how get works. It moves the pointer over to read the next thing. All right. Putback is sort of the opposite of get. And I've just placed a D in here just because it was something different. I could put back ch1, and then that would place an A back in the buffer because that's what ch1 contains. But you're not limited to the thing that you just read. So I just wanted to make that point. I could put back ch2, which would also put back the A, but you can put back into the stream buffer anything you want. So let's go ahead and put back the letter D. So since put back works the same way as get, only in reverse, the first thing we're going to do is we're going to move the pointer back over to the first location in the stream buffer, or the previous location in the stream buffer. And then what we'll do is we will place a D right there in the stream buffer. So we put back a D. So that's how putback works. It's the opposite of get. Remember that get will remove the character from the stream and then move the pointer over. Well, putback is the opposite. So we move the pointer back over to the previous location, and then we store whatever single character we want in that location. And in this example, I'm just putting back a D. So the next statement after putback is cin.get ch2. All right. Well, we grab the D and we place that into ch2. ch2 contained an A, but since we're placing a D there, the A gets clobbered. And so the D is overwritten, or the A is overwritten with D. And then we move the pointer over, and B will be the next thing read. If there is another get statement or some other statement that reads from the buffer. There isn't. Let's just pretend that the program terminates after this statement. Then the B
function. The next function is putback. Putback is the opposite of the get function. So putback will move the pointer to the previous position, and the putback will put the input character in that position. So putback is the opposite of the get function. Let's return to our slide so you can see how to use peek and pullback and its difference to the cin.get function. I will skip this example. This example is from the textbook. Then I will go to this exercise. This is also from the textbook. In this program, we use cin.get to read one character from the user. And if this character is not the new line character, then we will enter the while loop. And initially, we have the count variable. It's set to 0. And if count is an even number, then we will output the character ch. And after the if statement, we will increase count by 1, and we will read one character from the user. And now we can run this program. Suppose the user enter 0 space 1 space 2 space 3 space and so on. And what is the output of this program? The output of this program is shown in the second line. So the second line is the output of this program. And we can see the next page. In this page, I made a table. The first line is user input, and the second line is the value of count corresponding to each vector, each character. So for the first character, count is 1. The second character is space, so its value is 1. So we see the value of count increase by 1. And only when count is an even number, CH will be printed. So the highlight, the orange highlight means this character will be printed. So 0 will be printed, 1 will be printed. So so you see that the program output is this one, and this line corresponds to the orange highlight in the first row. The next example is similar to the previous one, but we modify one statement. Here we use cin to read one character, and previously we use cin.get to read one character. So exercise 18 is different from exercise 17 in that we replace cin.get with cin right shift operator, and we use the same user input. So here the user input is the same, but the program output is different. And I also made a table to show the value of count. We see that the first line is the same. The first line is the same row as in the previous exercise. However, the value of count is different. Here we know that for the white space, there is no corresponding count because cin will skip white space. So the white space is not read by cin. So we do not have corresponding count for the white space. And know that only the even number, when count is even, CH will be printed. So here I highlight the character corresponding to when count is even. So the program will output 0, 2, 4, 6, 8, 1, 1. And you can run this program by yourself. Actually, this program never terminates because cin cannot read the new line. So cin will never be the new line character. So this program runs forever. And you need to type Control C to interrupt this program. We almost finished this chapter, and below are some questions for you to test yourself the knowledge about strings. The first question is, how many characters. Here, the character includes the null character backslash 0. So how many characters are present in each of the following constants? So let's see the first one. The first one is a character because it uses single quote. So the first one is a character. So this only contains only one character. The second one is a C string because it is enclosed by double quotes. And for C string, the terminator is the null character. So for B, this constant has two characters, backslash n and backslash 0. For the third, for constant C, this constant has 4 plus 1. We need to plus the null character. So for C, we have 5 characters. And for D, we have, we know that here is the backslash n, and the backslash n is 1 character. So we have 4 plus 1 and plus the null character. So for D, we have 6. The constant D has 6 characters, and you can use size of to know its size. For example, here you can use size of we see that this C string has 5 bytes, and 5 bytes means 5 characters because each character occupies 1 byte, and this C string contains 5 bytes because we need to include the null character. And if you add backslash n, and here we add 1 character, so this C string contains 6 bytes. So we need to include the null character. However, if you use string length, this is defined in C string library. This function does not include the null character, so this function will return 5 because this function does not include the null character. Then let's go to the second question. This question is to determine whether the following three arrays are equivalent. Equivalent means the same. Whether the following 3 arrays are the same. We see that the first 2 are the same. The first 2 are the same because double quotes means a C string, and for a C string, the last character is the null character. So the first 2 arrays are the same. However, the third array is different from the previous 2. because the third array does not include the null character. So their array size. So the array size of the third array is different from the previous two. So the array size of STR3 is 5, while the array size of the previous two is 6. Next, let's see a related example. The next example, we specify its array size inside the bracket. In the previous example, we didn't specify array size inside the brackets. So here, now suppose we specify array size. So both of the 3 arrays contain 10 elements. Now we need to determine we need to determine whether the 3 arrays are the same. Let's take a survey. If you think the three arrays are the same, please raise your hand. If you think the 3 arrays are the same. Oh, okay. And if you think the 3 arrays are not the same, please raise your hand. Oh, okay. So the second one, most people select the second one. Actually, the answer is the first one. The 3 arrays are all the same. The 3 arrays are all the same. This is because let's see this. The first two arrays are the same, and we see that this character array has 10 characters, but we only specify the first 6 characters. We have four characters not specified, and recall that according to the C++ rule, the unspecified if we use assignment to initialize an array, the remaining elements will be set to 0. So the remaining 4 elements will be set to 0. And so this is the same as the same situation is applied to this array. The remaining five elements will be set to 0. And you might wonder, is 0 the same as the null character? The answer is yes. 0 is the same as the null character. You can look up the ASCII value table. Here is the ASCII chart. You can find the decimal value of each character, and for the null character, its decimal value is 0. So 0 is the same as the null character. And therefore, if we return to this example, we notice that for STR3, the first 5 characters are HELLO, and the remaining 5 elements are 0. And this is the same as STR2, because for STR2, the first 5 characters are HELLO, and the sixth character is the null character, and null character is 0. and the remaining four elements are also 0. So the three arrays are the same. I think time is up, so let's take a break for 10 minutes. Hello, let's return, let's continue our class. Previous we saw this question. We want to know whether the three arrays are equivalent. And actually you can print, here is the str1 and str3. And we can use for loop to print each element. And here I perform typecasting because we cannot see the null character. So here I perform typecasting to integer value. So we can see the value of each element in str1. The remaining, the last five elements are 0. So this one is the null character, and the null character is 0. And I also print each element in str3. And we see that the remaining, we only specify the first 5 characters. And the remaining 5 elements are set to 0 according to the C++ rule. So the two arrays are the same. Let's go to the final question. For this question, we need to determine which of the following arrays are equivalent. You can practice this. We see the str1 should be the same as str2. And str3 is different because array size is different. So and str4 is str4 is the same as str1 because both have 6 elements, and str5 is also the same. So you can verify that. str1, str2, str4, str5, and str6 are all the same. The 5 arrays are the same. You can verify this by yourself. And the last 3 arrays are also the same because they both have 7 elements, and their contents are also the same. You can verify this by yourself. And I will skip this one. So strcmp is for C string. So you can skip this. And we have finished this chapter. And the next, we will go to the next chapter. The next chapter is sorting. The next chapter is sorting. So you can open the second PDF. let's review. Let's review first. Let's review how to use the sorting function. Now suppose we have integer array and we want to perform sorting. We want to sort this array in ascending order. So here I print this array. So let's see the array elements are 2, 3, 1, 4, 5. Now suppose we want to perform sorting, then we need to include the algorithm library. And here I use sort. This function is defined in the algorithm library, and we need to specify the range we want to sort. So I want to sort the entire array. So the first is a pointer pointing to the beginning, and the second one is also a pointer. The difference between the two pointers, this is the number of elements we want to sort. So we see that after sorting, this sorting will multiply the elements of this array. So after sorting, the array elements becomes 1, 2, 3, 4, 5. Now, if you want to perform sorting in descending order, then you can supply a comparison function. So actually the sort has a different version. We can. Here is the manual of sort. Here is the manual of sort, and we see that this sort has two versions. The first version has two inputs, and the second version is the customized version. This version has 3 inputs. The first 2 inputs are the same as the first version, and the third input is a comparison function. So if you want to customize sorting, you can provide a comparison function to this sort function. Then I will demonstrate. So now suppose I want to perform sorting in descending order. So here I will use the second version. So I provide the comparison function, and we need to define this compare function by ourselves. The return value is a Boolean value. It's either true or either false. And this comparison function accepts two inputs. The inputs are the elements inside this array. Since each element is an integer, so the data type is int, because the data type of the element is integer. And here we need to perform comparison. We compare A with B. So if A is greater than B, then this function returns true. If this comparison is not satisfied, if A is not greater than B, then this function returns false. So if you run this program, it's a typo. So this function will this sorting will perform sorting according to this comparison function. So the sorting result is 5, 4, 3, 2, 1. It's in descending order. And if we want to return to ascending order, you only need to modify this comparison operator. This sort function is very powerful. This sort function can sort any data type. So you can sort integers, you can sort strings, you can sort your own data type, as long as you provide comparison function. So next, I will introduce how we can sort strings. Here is we can compare two strings, but this comparison is only supported for C++ string. We can compare two C++ string using greater than or smaller than, but we cannot directly compare two C string. So you cannot directly compare two C strings. So in this example, here I declare a C++ string, and I use C string to initialize as its initial value. And if we, so here is Bill, and Camel is here. And Camel is smaller than, Bill is smaller than Camel. Because this is according to the alphabetical order. Here, alphabetical order means the dictionary order. So A is before B, and the B is before C. So this is the alphabetical order. This is also known as the dictionary order. So here you can try to compare two C++ string. So we can, I will open another editor. here I use the comparison operator to compare two C++ strings, S1 and S2. If S1 is less than S2, then result is true. Otherwise, it's false. So the result is result is true because S1 begins from B and S2 begins from D. So in alphabetical order, B is smaller than D, so S1 is smaller than S2. You can modify other strings, for example, bell. So bell, if we can compare Bill with bell. The first character are the same, so we need to proceed to the next character. We need to compare I with compare E. And in this example, I is larger than E. So I is larger than E, so this operator will return false because I is larger than E. So result becomes 0. So if we compare two C++ strings, the comparison is according to alphabetical order. Here is one example. Now suppose we want to sort a vector of strings. So here we want to sort a vector of strings. We can first print each element. So that's first, let's print each element. And then we want to perform sorting. So next we will sort this vector of strings. So to do this, we can code suppose we want to sort the entire vector. So we need to supply the range we want to sort. And here we need to use iterator because this is a vector. So we use begin to return an iterator pointing to the first element. And the end is also, the end function will return an iterator pointing to begin plus size. So here you can ignore the comparison function because this string data type has the comparison operator. This data type provide a comparison operator. So the sort will use this comparison operator for sorting. So here we don't need to we don't need to supply the comparison function. And we see that after sorting, the array, the names vector is in alphabetical order from A to Z. Now suppose we want to modify the order. For example, we want to in descending order. We want Z in the first position. Then we can supply a comparison function. Now we can supply a comparison function. The return data type is bool, because the return value is either true or false. And the comparison function has two inputs. The data type is the element of this vector, so the data type is string. And the return value is the value generated by this comparison operation. So we compare S1, S2. So this is string comparison. And you can change the order by use different. You can change smaller len to greater len. Then we can perform sorting in descending order. So we see that if you change if you change smaller len operator to greater len operator, then the sorting is in descending order. And actually, we can perform sorting according to different requirements. For example, if you want to sort according to string length, we can also perform sorting according to string length. For example, bill is we can perform sorting according to length. Bill only has 4 characters, and the camel has 5 characters. So bill is smaller than camel because its length, bill is smaller than the length of camel. And to do this, we can customize the comparison function. So here, it's very simple. We just call size or length. You can use size or length. So here we compare the size of 2 strings. And we can. So if we change the implementation of this comparison function, and we see that this is the output after sorting according to string length. Alexander is the largest because its length is the largest. And if you want to reverse the order, you can change the comparison operator. The next slide, I will introduce stable sorting and unstable sorting. Now suppose we have input array like this. We notice that we have 2, 5. The two elements have the same value. And stable sort means after sorting, the relative order of record of elements with equal keys are the same. So this means if we use stable sort, the relative order, so 5 is before 5 star. So this order remains after stable sorting. However, unstable sorting does not guarantee this. So for unstable sorting, 5 can be before 5 star, or 5 can be after 5 star. So unstable sorting cannot guarantee relative order of equal keys, of equal values. The next one is the next slide provides another example. Here we define a data type. We define our own data type. We use struct to define a new data type, and this will be introduced in the next chapter. In next chapter, we will show we can define our own data type using structure or class. Now suppose we define our own data type. This data type has 2 members. The first member is name, which is a string. The second member is score, which is an integer. And we can use this data type to declare an array. So we use this data type to declare an array with 4 elements. And we can initialize the value of each element. For example, at index 1, name is set to Alice. And at the index 0, name is set to score. Score is set to 90. And then we can perform sorting. We can perform sorting according to the score of each element. And to do this, we need to supply a comparison function. So let's see this example. use a for loop to print each element. So let's see. So we see this array. This array has 4 elements. The first element, its name is Alice, and its score is 90. Now suppose we want to perform sorting according to the score. So now suppose we want to perform sorting, and you can try. We can use the sort function in the algorithm library. And if you compile this program, you will find some error message. The error message is no match for operator smaller than. And this is because this data type is defined on our own, and we didn't implement the small than. We didn't implement the comparison operator. So this function does not know how to compare 2 elements. So if we want to sort customized data type, we need to supply the comparison function. And here is the comparison function. Here is the comparison function. This comparison function returns a Boolean value. It's either true or either false. And the 2 inputs are the elements we want to compare. So its data type is student, because the data type of each element in this array is student. And we want to compare the 2 elements according to its score. So here we compare A data score with B data score. And now suppose we want to perform sorting in ascending order. So we use smaller than. So this will sort this array in ascending order. So we see that after sorting, smaller scores appears in the first element because we perform sorting in ascending order. And you can also perform sorting in descending order. So if in descending order, 90 appear first. And we notice that usually we don't use this function declaration. Actually, we perform we prefer this function declaration. Because if we use this declaration, we use call by value. And call by value means you need to copy all the elements inside this structure. So call by value is less memory efficient. So usually we prefer to declare compare function like this. We use call by reference. And to use call by reference, we add the ampersand operator. This is more memory efficient because we don't need to copy the entire structure. We only need to send memory address, and memory address usually occupies only 8 bytes. And here we also add the const modifier. And because we didn't modify A or B inside this function implementation, you can also remove const, but a const is for protection, to protect you accidentally modify A and B. So const is a protection, and we usually use this modifier when we implement the comparison function. And actually, we can also perform sorting. You can also perform sorting, but according to student's name. So you can perform sorting according to name. The result will be different. You can determine what is the output if we modify the comparison function like this. So I'll change it to smaller. So if we change the comparison function like this, can you know what is the results after sorting? So if this is the so I think the output will be Alice, Bob, Charlie, and Davy. So we see that if we modify comparison function like this, this comparison is according to comparison to strings. So Alice is smaller than Bob. Bob is smaller than Charlie. Charlie is smaller than David. This is according to the alphabetical order. And we can discuss stable sorting and unstable sorting. For this example, if we use stable sorting, now suppose comparison function is the previous one. Right? The comparison function is suppose we compare A dot score with B dot score. So this is in descending order. So the result is like this. So it's in descending order. So 90 appears first, then 65. And stable sort means relative order is maintained. So we see originally Alice is before Charlie. They are with the same key, with the same score. Both Alice and Charlie are with the same score. And after sorting, after stable sorting, the relative order maintained. This means Alice is before Charlie. So we see that after stable sorting, Alice is before Charlie. And similarly, Bob and Davy are with the same score. And after stable sorting, Bob is still before David. So we see that Bob is before David. But for unstable sorting, we cannot guarantee the relative order. So we have no guarantee Alice is before Charlie. So for unstable sorting, Charlie may be before Alice. They are with the same values, with the same scores. And similarly, in this example, David is before Bob. The relative order is modified. So actually, for unstable sorting, for this example, we have four possibilities. So here I write the output may vary. So the output is not unique for unstable sorting. The position of Alice and Charlie can be exchanged, and the position of David and Bob can also exchange. So we have 4 possibilities. So if you look up the manual, you will know sort is unstable sorting. While if you need to use stable sorting, you need to use stable sort. Both functions are provided by the algorithm library. Actually, one thing I want to mention is that sort is very powerful because sort can sort any data type. The sort function can sort integer, double, or strings, or any data type. So sort is very powerful, and it is also very elegant. You see that you only need to specify the range you want to sort. You only need to supply the comparison function. So the sort function is very elegant and powerful. And if you want to design a function, then your function should be like this. It's very powerful and elegant. Actually, you can compare the sorting function in the C programming language. In C programming language, we usually use quick sort. So you can compare quick sort with sort in C++. So this is the Q sort in the C library. We see that here is the quick sort in C language. In C, if you use C language, we usually use this Q sort to sort arrays, and you can see its syntax. Its syntax is a bit complex. You need to supply the number of elements and the size of each element, and we also need to supply the comparison function. And you can see that this comparison function is very not very intuitive. You need to implement this comparison function by pointers. So you can see this comparison function is not very intuitive compared to the one we define here. You see the compare function for the C++ sort is very compact and easy to understand. And if you compare this with the comparison function for the Q-sort, so you will find sort is more convenient than Q-sort. And we have finished this chapter, and the class, I think we can end the class, so we can dismiss, class can dismiss.